You've seen this happen a million times, right? Some stray piece of metal, a paperclip or a nail, suddenly just leaps across space and, thwack, snaps onto a magnet. It feels a little bit like magic every single time. But what is actually going on there?
I mean, think about it. There are no strings attached, there's no physical contact, at least not at first. This force just acts across empty space, making an object seemingly come alive. It's one of those everyday things that, when you really stop to think about it, has one of the deepest explanations in all of physics.
Okay, so let's pull back the curtain on this magic trick. We're going to go on a little journey, starting from the absolute smallest particles in the entire universe and scale all the way up to the massive technologies that literally run our world. We're going to uncover the secret.
Now, to understand that magnet holding a drawing on your fridge, we have to shrink ourselves down. I mean, way, way down. We've got to go to the atomic level. Because the secret to this incredible large-scale force, it all begins with one single tiny electron.
So here's the wild part. Magnetism isn't just something that happens to special metals. Nope, it is a fundamental quantum property of particles themselves. You know how an electron has a charge and it has a mass? Well, it also has this other thing called spin, which, for our purposes, basically means every single electron is its own microscopic little magnet. And that, of course, leads to a pretty logical question. If every single atom is made up of these tiny little electron magnets, then why can't I stick a tree to a rock? Why isn't every single thing in the world just one big magnet?
Well, the answer is all about teamwork, or I guess a lack of it. In most materials, like you see over on the left, electrons like to pair up. One spins up and its partner spins down. And just like that, their tiny magnetic forces completely cancel each other out. It's a wash. But then you get to the special materials on the right. We call them ferromagnetic. Things like iron, nickel, and cobalt. They have these lonely, unpaired electrons in their outer shells, and with no partner to cancel them out, their magnetic forces are free to add up.
Okay, so a chunk of iron is packed with atoms that are all potentially magnetic. But if you go pick up a regular old iron nail, it's not a magnet, is it? So let's zoom out one level and figure out why.
So inside these special materials, the atoms get together in little neighborhoods. We call them magnetic domains. You can think of a domain as a tiny, microscopic kingdom where all the individual atom magnets have agreed to point in the exact same direction. They're a team.
And within the borders of one of these tiny domains, you have perfect order, total discipline. We're talking billions and billions of atoms, all aligned, pointing the same way, combining their magnetic strength into one unified force.
But here's the problem. In a normal, unmagnetized piece of iron, all these powerful little kingdoms are in a state of total chaos. They're basically at war with each other. One domain points north, the one next to it points west, another one points down. They're all oriented completely randomly, and all their forces just fight each other to a draw, canceling everything out. The result? No magnetism.
So this right here, this is the main event. How do you take that chaotic jumble of warring domains in a plain piece of iron and forge them into a single, powerful magnet? How do you get all those kingdoms to unite? You do it by bringing in an even bigger, more powerful force, an external magnetic field. Now watch what happens. The domains that just happen to be pointed in roughly the same direction as the external field, they start to grow. They expand their borders, they swallow up their neighbors. And the other domains? They're forced to flip their alignment and join the winning team. This process continues until pretty much all the domains are facing the same direction, united as one.
And that's it. That's the secret. A permanent magnet is really just a piece of ferromagnetic material where trillions of microscopic kingdoms have been forced by an outside power to stop fighting, unite, and point all of their collective strength in a single direction.
So pretty amazing, right? We started with the quantum spin of a single electron. We scaled that up to these atomic domains. And now let's zoom all the way out and see how this one simple principle of alignment has literally built the modern world we live in.
And that is not an exaggeration. I mean, honestly, without our ability to harness and control magnetism, the incredible technological progress of the last 2 centuries would have been absolutely impossible.
This force is literally everywhere. It's in every electric motor, powering everything from a tiny fan to a Tesla. It's in the massive generators that create our electricity. It's how your computer's hard drive stores every byte of data. It's inside MRI scanners giving us a window into the human body, and it's what allows high-speed maglev trains to float above their tracks. Magnetism is the invisible backbone of all our technology. And you know, this whole principle isn't just something humans figured out. The Earth's molten iron core turns our entire planet into a gigantic magnet.
That magnetic field it generates is like a shield, protecting all life on the surface from dangerous solar radiation. And it's the original GPS, the internal compass that animals like migratory birds and sea turtles use to navigate the entire globe.
Okay, so this brings us to one last really fascinating question. If a magnet can hold a piece of paper to my fridge for years and years, it's kind of doing work, right? But it's not plugged into anything. So does it ever run out of energy?
Well, the short answer is no. A permanent magnet isn't like a battery. It doesn't have a stored amount of energy that it spends. That neat alignment of all the domains creates a stable, constant field of energy around the magnet. The energy that makes a paperclip fly through the air actually comes from the potential energy in that field itself. It's a lot like how planet Earth doesn't use up energy to have gravity. The force is just there.
And that really brings us full circle, doesn't it? We started with something that looked like magic, an invisible, mysterious force. And now we know it's just the laws of quantum mechanics, scaled up trillions upon trillions of times. It's just a powerful reminder that so often, the fundamental forces that shape our entire reality are the ones we can't see at all.
So, from the tiny spin of one electron to the invisible shield protecting our entire planet, magnetism is this incredible force that connects the quantum realm to our everyday lives. The next time you see a magnet snap to the fridge, you'll know it's not magic, it's the universe showing you one of its deepest, coolest secrets. And it really makes you wonder, what other invisible forces are out there, quietly running the world right under our noses?